Hello and welcome to EXFO's Be an Expert training program on the Wideband Longitudinal Balance test. With the large-scale deployments of DSL into the field comes a demand from the providers to not only identify high-frequency disturbers, but also qualify loops in order to prevent crosstalk and maintain a high quality of service. We all understand that if a loop is capacitive or resistively unbalanced, you'll hear an audible hum on the line. The longitudinal balance test helps identify this condition on your pair. If your twisted pair tip and ring have an equal balance to ground, the signals being sent on each leg of the pair will effectively cancel each other out. If any imbalance is introduced, the pair is effectively impaired, causing hum or static on voice services, and for the DSL side, it manifests itself as slow speeds, lost packets, modem reboots, and everyone's favorite, pixelation of IPTV services. Even having a single unbalanced DSL pair in a cable bundle can cause severe crosstalk to other pairs and take a whole neighborhood down with it. The traditional longitudinal balance test measures the power influence on the line and subtracts the quiet line noise. A longitudinal balance of greater than 60 dB is largely accepted as a quality cable pair result. The fault with this test when it comes to DSL qualification is that it's all done using voice frequency tests. The wideband longitudinal balance test takes it a step further, does a swept measurement into the ADSL2+ and VDSL2 bands. This helps identify pairs which are susceptible to high frequency noise that would simply be passed over using the traditional tests. It also helps prevent installation onto a pair that could actually do further harm to your existing customers. The traditional longitudinal balance test is run against the quiet line. However, with the wideband test, we need to run it against an open pair. When looking at the results of a wideband longitudinal balance test, we've graphed the individual frequency results against the dB level. The graph of the wideband longitudinal balance test may look odd. However, we're not looking for smooth lines or gradual drops. We're only interested if any frequencies rise above the user-defined pass-fail threshold. If we don't see any rises above the pass-fail line, then the pair is balanced and capable of rejecting high-frequency interference. In cases where frequencies have failed, it's a sign that your pair has a resistive or capacitive imbalance. Any number of causes can be the culprit. Some examples are stretched cable, untwisted sections, water in the cable, or bridge taps. It's time to get your fault finding hat on and use the fault location test to chase your trouble down.